Good evening, good afternoon, good morning, everybody. Welcome on into the Dragon's Den. My name's Digital Dragon, aka Luke. Welcome on in. Heck, glitched, funky. You're bad on the spam. No problem, Tugboat. No problem. Figured you were going to be doing a countdown. Welcome on in. Hey, Glendon, how's it going? Bexy Beans and Tugboat sneaking on in. Sneaking on in. So welcome on in, everybody. So we're coming back today to work on our VzBot 235 build. We made some good progress on the last stream. You may notice there's a couple of new pieces sitting up here. I'm debating whether I want to reprint these or possibly, like I said, get the CNC versions. And the only reason I would reprint these is to do a dual color on them. So what I've started doing, flip the screen here, is rather than do like this, where the VzBot logo is just, say, embossed and kind of just nicely subdued, I did start going through and doing some pull up VzBot parts with the dual color using the AMS, showing off the logo everywhere. So things like this one showing off here. Now, one of the things that I would have an issue with is like this particular part here. It prints with this face down, and then trying to have a part that's a little bit debossed like this doesn't work all too well when this is facing down. If it was fully flat, it would work a little bit better, because I found when I go ahead and just select the interface that that is just the outline that it is selecting. It's not I'll say like bridging the gap. So I don't know if painting the sidewalls would force it to kind of bridge that gap better or not. So I may play around with this. This, by the way, is the mounting piece for the CPAP blower. So I at first thought, well, this would be going up against the metal, but then the more I think about it, I was like, then why even bother putting a logo on here? Because this is going to go up against a panel like this, so that logo would be seen. So I may be playing around with this to try and get this to print with the multicolor print. It's going to be on the back side of the printer. It's not going to be noticeable, of course, unless this printer goes to shows, which the plan is to have Black Box, this printer, and the Annex at least going to Midwest Rep Rap Festival, and then several others that may find new home. Bear with me because I'm sitting on your floor repairing a skirt, so won't be typing for. Okay, fix your skirt. Hopefully you're not trying to sew a skirt that you're actively wearing, because, wind up stabbing yourself. Actually, you're still repairing your bell skirt, right? So I'm sure it's laid out on the floor and you're trying. That's what our micron parts look like. The exact colors, actually, well, except for the fact that it uses custom filament. Yeah, so I'm still thinking about redoing a couple of parts for you, Tugboat. Um, I have printed the last part, which I don't want to show you because I don't want to give away the surprise. But a couple of the other parts, just in the way they're oriented when they print, I either need to change the print orientation and reprint them so that I get better logos showing, the Rook logos showing up on them. Or I'll do that trick where you'll notice like the sidewall of this print is still the darker or the base color. If I select that inner edge wall for the highlight color, it should bridge the gap easier that way, because then it will have a wall that it will then bridge across, versus this where it's trying to print that V in that slash just within the confines of that bottom shelf. It's kind of hard to say without pulling it up in a slicer and trying to show you. But today, actually, since the last stream, I did go ahead and put the handles on it. That's just literally going to make it easier to get on and off the table here as we continue to add more weight to it. Once again, I'm not going to add the build plate until a little bit later, just because why add 5 or 6 pounds to the printer if I don't need to when I'm moving it around. I did get the front cross braces put in here. And once again, my real decision is, do I reprint these with the logos embedded on them, or do I buy the CNC'd silver version and put those in place? The CNC'd parts for the 2 front braces and the top brace is like $90 for shipping. So they're not necessarily cheap, but based on the CNC work for everything else in here, they are very nice. And now I'm looking at mine with the quote unquote silvery, aka bare aluminum finish, versus the black anodized finish. And the black anodized finish was the one that he builds used on his build. And I'm kind of reviewing his build just to make sure I'm not missing anything. And I kind of like that finish as well. But will this VzBot be an enclosed printer? Yes, it will. Yes, it will. Yeah, you do. You sure do love surprises. I think you'll like this surprise. I think it came out well. The other thing is, so I did go ahead and order and get in a couple of things. One is just a large 24-volt power supply, because I need to see if this sucker is going to fit on the Rook 2020. If it's not, I need to know now so I can come up with a different thing, because there's 2 ways that you can do the Rook 2020 Mark II. Use an LRS power supply, or you can use an external power brick. Okay, so this is the LRS 224. The Morn Sun that came with the Fabrico Rook kit, I believe, is dimensionally smaller than this, and it will probably fit a little bit easier, but I just need to see how this fits. In fact, let me just grab something right here and do an eyeball off camera real fast. And that off camera eyeball tells me everything I need to know. And that's the fact that this will not fit where I was hoping it would fit. So I either need to get actually I think a UHP would still be just as long. So what I probably need to do is get either get a Morn Sun, or we're going to have to go with the external bricks, which means I'd have to possibly reprint a part or two, but we'll see. We'll get that figured out. I've got time before I do a build stream on it, and I still need to get the parts sent out to you. The other things that arrived, and I'll open up one of these because they're going to be, I've got 2 of each of these. This is So this is the HGX extruder. This is, I got this off Amazon, but it is the same one that you would get off of AliExpress. So this is the linked extruder in the BOM for the Rook 2020. So this uses the larger, the dual larger geared drives. So the HGX is a knockoff of the LGX. So it's kind of like a skeletonized Sherpa, which uses a LGX type larger gear here. So these will be the extruders that we'll use. So I got that in. And I just know that this would be things that would have to be ordered outside of KB3D because I know he doesn't stock these. And then the other piece heater. There's a glass bead thermistor. Okay, so these are fully disassembled. Nozzle. And this is, oh, that looks like a spare nozzle. Interesting, cool. So once again, they linked to a knockoff of the Bamboo Labs hot end. So I grabbed one that had decent enough reviews. This will be the hot end that we'll use on the Rook 2020s. There was two types that you could use. I decided to use these because these are kind of all the rage lately. And if you wanted to or needed to get one, you could actually go up to standard bamboo style versus knockoffs, or these are readily available on Amazon and all. So, so the size of the build plate on the VzBot, this is a 235. So this is going to be basically an Ender 3 size build plate. But mind you, it does have all the little, bits and bobs and spares in here. So, yeah, I don't know why all of this is not in the bag, but the wonders of AliExpress. So it does look like we'll have to build our hot end, right? Ceramic heater, and once again, our thermistor, and we're probably going to have to cut this off and do different wires on here. So just be aware. May need to do some soldering or get you the solder connectors that I showed you guys before if you don't want to do soldering. But these are what's going to be used on our Rook 2020 Mark IIs. So one set for me, one set for you guys. This will be in the box with your printed parts and the frame, which I still need to cut the frame. I was planning on doing that this weekend, and my plans got changed on me. Plans got changed. You can solder it, it's all fine. Yeah. Well, and there's two ways that you can do it. You can literally, my suggestion would be not to use JSTs, and if you want to use like wires rather than going all the way back to the board, I would say swap them out with microfit JSTs, and microfit 3 connectors like you would get on Cruiser or something like that, because that way that would enable you to at least disconnect them at the tool head and then take the tool head off and work on it. The other option of something that you can do, not needed, but it's what I did on mine. Is you can either do like an umbilical, um, or a EBB 36 CAN bus board. It'd really be way overkill for a printer that size, but it would enable all the connections to be on the tool head, and make life a little easier maintenance. But just wanted to kind of show those things off real fast. And we're going to get back going on the VzBot. So one of the things that I was looking at was the belting process. And it dawned on me that things like our XY joints here, these use lock nuts. So I'm not too concerned about those. Yes, these bolts that go directly into our carriages have not been loctited on the XY rails, or at least not by me. So that is something that we have to be cognizant of. But the one thing, and I'm not going to worry too much about that. I have yet to have any of these back out on any of my printers, so I'm not worried about that. I may Loctite everything up here at the top as we're building that out, but I'm not going to worry about taking the X gantry back out to pop these out, because looking at the way these go in, it's not going to be easy to get these off without disassembling the entire joints, and I really don't want to do that. Lazy. But what I do need to do is take off all of the grub screws, put Loctite on the grub screws. So on our front motors, you need to make sure that one of the grub screws is on the flat of the motor. On the rear grub screw, we need to make sure that none of our grub screws are on the flat of the motor shaft. There's a specific reason for that, and it's going to be required because we're doing a full Core XY belting with two motors. We need to make sure and synchronize this motor with this motor and this motor with this motor. And in order to do that, we need to make sure that what we'll do once we get our belts done and we get ready to tension our belts, we're going to loosen the grub screws on the back idlers or the back motors, so that these motors will synchronize and mesh with these motors, front ones. Okay. So as it starts to turn and as we tension, it will allow these the teeth and the pulleys on the back motors to remain aligned as we're doing the tensioning. Then once we're done tensioning and we get the right tension on our belts, then we can lock down these locks or the set screws, making sure that they're not on a flat. Okay, apparently that's going to be critical based on what I was reading and watching in Vez's videos. Then once again, there will be a tensioning mechanism that we need to put in here. I didn't do that yet, thinking it had to go through the plate, but it doesn't. The plate can actually slot down over these tensioning bolts that will go in here. So I still need to do those. Go through here and see which screws I use. Might actually have to even look at the. Oh, interesting. So the knob uses a bolt that is directly threaded into nut on. You guys can't. I apologize. We have an ad break that's getting ready to start in a couple seconds here. So, in looking at this CAD blow up and let me what we're looking at is this bolt right here, and this is not a socket head cap screw. Rather, in the printed parts, it would be a captive nut in the printed part, captive nut in the printed like knurled knob, and a just a threaded like it's a threaded dowel is sort of what it is. It's not an actual screw, but a fully threaded bolt. And I just realized I need to move some things around to get access to my parts. Here. Needed it. But for whatever reason, my purge on the on my X1C is not always dropping down. Sometimes it tends to pull it back into the build plate, and then it stops, you know, saying that there's spaghetti. In this case, this was the ooze that they then purge between the first layer after it checks the first good. So good thing is that's not a multicolor print, so it should be able to print the rest of that without anything. Sorry. Rest of the black box. Oh. And then the other thing that I posted about that arrived, let's try not to dox myself, was the Prusa MMU3 kit. So once we're done with a VzBot, we may get into this if we have time between now and Murph. If not, this is going to be sitting here until after Murph, which is at the end of June. So I can tell you, Tugboat, your logo itself, the boat and stuff, take your image, bring it into Fusion 360, and just use it as a construction plane, and then use the line tool to create the boat shape, and then the circle tool to do the radius or the band around it. I know that because I've created that part of it, but I cannot seem to figure out what font you used or was used on your behalf. That's the thing I don't know, is what actual font was used. So I can't replicate that part because let's just say I don't have the patience to sit there and try and recreate that by doing all the lines myself. Or at least not after spending all day looking at spreadsheets. Because, yeah, that's how I've been spending my days lately. All right, so let's get the VzBot stuff accessible. The details and stuff. We might today know that we're going to need to get into our standard parts because that's where all of our bolts, bits, and bobs are at. Pull the rest of this over in case we need to jump between here and there. So I should have, so I don't know if you can tell, but down deep in the cups here, probably can't. But there are spots for the screws to, or the screw, M3 bolts to go in here. And then we'll add the threaded, kind of hard to call them bolts because they're really not bolts. They're just lengths of threaded rod, basically. Now if I can figure out where those were. 4mm pin, 2mm, or 5mm screws. Odd and 5 screws. Nope. Up for the okay. 4. Hertz. A question. When's the election? Like November, right? I've got about how many more months of spam calls that are going to annoy the hell out of me while I'm doing things? Actually, I thought these were going to go down, but they don't have a slot in them. We will have to mount these, and so these are going to fit here with this hole going into that hole in the printed part. And I thought there was a slot there, but there's not. So we are going to have to mount these before we do the tensioning, which means we'll have to put the little there's little side strips that go down here of panel. So we'll have to get that there. We're also going to need to get this out, which is the CNC parts for the head, because we'll need that before we do belts. I'm not sure if we're going to mount Goliath tonight or not. We'll see. I don't necessarily need to mount the extruder in Goliath, but maybe we will. Maybe we will. We'll see how the stream goes. Partly that's just because I need to dig around in that manual as well. And I'm at a loss now. Not finding those screws. Bolts. Motherboard, 1, 2. Not be there. Yeah, I just need to actually dump these things out and sit. Hey, Royal Nomi, how are you doing? Abatus, welcome in. Welcome in, y'all. Because I'm pretty sure that I laid eyes on these 2 screws and was like, wow, those are weird. Why don't we have screws or bolts without heads on them? Let's look again. These are pulleys, 8mm, sunk 30mm, 40mm M4 barrel head. That's what we're looking for. It will be in our M4s, not our M3s. So let's look through our M4 stuff. Or nuts. There we go. That's what I was looking. These are just M4 barrels. So we're going to need that. And a couple of our M4 nuts. There's no need to put Loctite on these because they're going to go straight through and into this lower part here. And one side has a head capable screw, so it's basically like a huge M4 set screw. Tighten this in till it bottoms out. Sides. Sides. Got that inserted on each side. Motor mounts go in, we do that. Now once again, what I do want to do real fast is pop these off before I start putting other things in front of them and just make sure that there is Loctite on our set screws on our pulleys. I'm just going to take these off one at a time so that they don't move. Make sure that they've got Loctite on them and that they're up. So let me run a check real fast and see all here. Hey, Evil Diesel, what's up? Royal Nomi. Oh wow! So we got Two Wolf Design, 8H Bidevs, Pro Abidas, SMR Miu, Audi Glaze, Bear Gryllis, Bexy Beans, Donk, Rapsnet, Juice Falchion, welcome in. Evil Diesel, Frame Rates, Linden, Mark Zink, Mr. Wizix, Ramon, welcome on in, Ramon. Long time see, Regress, They'll Know Me, Parsai, Trent Father, Timor, Tugboat, Boric, Dusty, welcome on. Welcome on in. So once again, we're just going to put a little bit of our thread locking compound on these set screws and put those back in while we have easier access to things. And I'll be 100% honest with you, I'd much rather try and get belts run some before putting these little tension plates on, just because I think it'll be a little bit easier to get in there and do things, but maybe we'll see. I'm trying to follow directions because this is a new build for me. Ooh. Is it the... Okay, Royal Nomi. Well, hopefully they're doing, whatever happened, they get well and they get out soon. Soon I print a dog and a stick. Okay. Sure there's something behind that. Hey, Mr. Wizix. Oh, by the way, we do have our coffee. I've got, believe it or not, this is some reheated Dunkin' Donuts because Mrs. Dragon got me Dunkin' Donuts more around 4 than 6. And now this is some Black Rifle Company Tactus Squatch, which is a dark roast. Royal Nomi just catching the edge of the pile. Yeah, this is the VzBot build. So Nero 3D did a 330 version of this printer, and it was actually taking it back apart today. He's swapping the electronics out for a Kraken, and he'll also be, or at least he's talking about potentially putting a tube hot end on his, which, hey, I've got both of those things, but maybe down the road, I think what I really want to do is build this the way it's supposed to be built, and then, if needed or desired or wanted, go ahead and swap it out. I understand the desire for going to something like a Kraken because it can take the 48 volts directly rather than having to use the external drivers, which just adds a lot of wiring complexity. But kind of one of the neat things about this build is its added complexity. You know, we've done an Annex Engineering K3 with dual power supplies. We did a black box, which adds its own little bit of complexity to things. So, you know, complex is not necessarily bad, right? But at the same time, simplicity, there's something to be said about simplicity as well. And like I said, I'm just pulling the set screws out one at a time and swapping, or not swapping them, but adding some Loctite to them. So join on your phone so you can type. Okay. Hey Bexy, welcome in from the floor. How's the weather down there? It has been raining here all day. I went over to help Evil Diesel pick up a desk. He'd actually had on hold since Saturday when I was out of town doing some family things. And so he needed to get it picked up today. So we went over to get it picked up today. And yeah, it's been raining all day. So we went and picked up a desk in the rain. So that was a blast. You just want to win. Instant coffee? Yeah, no instant coffee. This is it's Keurig pod, so I'm not doing like French pressy stuff yet. Partly because I look at it and I just can't bring myself to buy all the stuff to do a French press setup. But maybe one day, if I start actually field camping when I hunt instead of just staying at my parents' house and going to my hunting lease. Pesla should either be napping or pounding energy drinks because she starts streaming at like some stupid hour tonight, right? Like after Zombie Hedgehog finally stopped streaming, which is like a weird thing. Things we agree to do. Okay, so I did actually put Loctite on here after I said I probably wouldn't put Loctite on these front pieces. And then once again, I am going to try and wipe off any excess that oozed out the front because there is going to be an acrylic panel here, right? So I just want to make sure that that stuff is squared away or cleaned up before we wind up putting that acrylic panel on here, because I'm not sure what it'll do to acrylic. And actually, they might be PC panel. Might be polycarbonate panel. But anyhow, those are now done. We've got the front pulleys done. We got our set screws. In essence, that's what they are, huge set screws. I'm going to turn this around And once again, I'm going to do the same thing on the back here. One thing I'm going to do is turn these around and just see if there is a flat on these. And believe it or not, I'm not seeing a flat. So they must have gotten some straight shaft, or not straight shaft, but circular shaft motors from LDO. Once again, we're just going to put some Loctite on these. And I'm not going to like tighten these down. I'm just going to bring them into contact. Because once again, when we go to do the belts on here, we'll want these loose so that the pulley can self-align on the belt and the teeth. That just dropped down some, so make sure that we put this back up at the right height. Now, we'll actually maybe put a nug-a-dug on one of them. These get lined up with our smooth pulleys on each side. Take note of that. Once again, I'll make sure that one of these is tightened up and the other one's not fully tight, so that later, well, I guess I can tighten them both up. We're just going to have to remember to loosen these later on when we go to do our tensioning, which will hopefully happen tonight after we get our belts run. And that's why I don't plan on doing like a full Goliath install just yet. I just want to get the print head skeleton in place so I can get the belts run, and then we can add everything else. Because part of the process of building that aluminum tool head is going to involve, having to run the belts, and it's going to be a lot easier to do that without having everything installed on the tool head to get in the way. Once again, we're getting everything Loctited in and then just wiping down the excess so that it doesn't get on any printed parts down. And I want to get the belts run, and then we'll worry about the tensioner. So we'll go forward and then come back type of thing. Because what we're seeing here is, like I said, there will be little kind of like panel strips that go right down the side on each side. And that's going to mount this piece. So we're going to have a panel strip. This is going to come in. We'll mount 4 screws. So 2 of these screws here will be with T-nuts or roll-in T-nuts. This is going to go right into an M4 nut that we've already added. And then we'll put a nut on this. This will go on this way. And we'll start screwing this down. And this will become the tensioner that as we hit the panel, it'll start pulling this screw out, which will move the whole motor mount. So that's what these parts are going to be used for. Some of these other parts here are going to be for the actual tool head itself. So let me go ahead and open these parts up. Once again, this is the skeletonized aluminum tool head. We'll have something like this for our tube in the form of the Calamity tool head. But this will be basically a series of parts that we're going to screw together to make the tool head. And there is, I'll say, like a hybrid. So this is a fully CNC version of the tool head. There is a hybrid version, and I believe there might be a full carbon fiber kit, but I'm not sure if there is a full carbon fiber kit. But what I have seen is our little running man. This is our little dude that's going to hold the fan, and at least the bottom plate. I think these two and possibly even the top plate can be carbon fiber. Once again, these are very nicely machined. The tool, all of the way on. Here we go. When they did the belts, and I believe they've got all of these CAD files. So if you really wanted to, and you had, I don't know, say a Mellow mini mill, you could actually cut these pieces out yourself, either with a Mellow or Carvera or what have you. So we're going to be installing or building this CNC tool head. It should be all the same parts. I'm going to have to scroll forward here. Here's continuation of building the rear idlers. So the VzBot print head is based on an EVA design, but it's not 100%. Where VZ235 and 330 have a different belt path in regard to the print head, so the back and front plate for the print head are not the same. Use the one found in the VZ235 repository. Also, don't forget to check the community mods section on GitHub to find your configuration. Here's our X-Rail that's already installed. Talks about going through and installing it, which again, it's installed. Basically, we had taken the two screws and the little bump stops out on each side. We put the two screws back in through the printed parts and got it in there. Worry about this, they're already mounted. I did put the guides on them though, and all the guides were good. Now it talks about doing the belt, but you can see that it never once told us how to actually do our tool head, our print head. So that's where we're going to need to go and possibly look at so it really doesn't show us the instructions on building the tool head here. Let me go to GitHub. Excuse me. And see if I can find it. Hey, Pezliz, welcome on in. Welcome on in. So we're out here, we're looking, the aluminum parts are why the front motor mounts, rear motor mounts, idlers, all drive, still not a toolhead assembly. Sorry, I'm over here looking at the CAD, not the CAD, but the GitHub Easy Print Head. This is what we're looking for, is to set this up. Printed, really like. Jump out there and see if there's Easy Print Head printed version. Let's see if we can find the aluminum version of the print head. There we go. VZ Print Head CNC. Instructions. This is what we're looking to put together here with the parts that we have on our table right now. Instructions. And that's where we're going to start. So we're actually going to follow this. So let me switch back over here. Change the focus for our little window on the right to home. Moving the window. Go. And we're going to need to start with some. I'm going to take this and move it to the side for just now. And we're going to need to look for some specific screws. And the question is whether or not it's in our M3s here, or if it's in the other package. We're looking for M3x6 ultra low profile, which is basically looking for these flathead screws. So that's the 8s. Socket heads, M3x6. There we go. And these are not, I'll say they're not countersunk. They're actually flathead screws. You see if I can pull one out here. 4 of them anyhow. Let me see if I can get this to focus. So you'll see that screw. It's not a countersunk. It's actually got a flat head on it. Close and that's what we're looking at. It's a flat head, not a countersunk screw. So the two parts that are going to go into our the cable chain, or not the cable standoff. I apparently either did not print or I have a different version of it. This might be the one that I'm going to use because this is for the CPAP piece. So I think we're going to have a different cable chain holder. So we're not going to worry about that piece that goes up on here just yet. We're gonna hold off. We won't put that piece in, which is top printed piece. So I thought I had printed that out. The rest of the printed parts go. I did. Oh no. No, no. So if I printed them, if I printed that particular piece, then I set it somewhere that I cannot find right at this moment. But for the life of me, I think that that piece may not be printed for the CNC version. But if I find it, we will add it later. That is going to be okay. We do want to use Loctite on all of these screws. These are our 2mm hex driver. And got this piece, this piece. These are through holes on this piece and threaded holes on this upright piece. So we just need to make sure the little tabs are coming towards the inside. Line this up and get a screw started. Second one going. How's everybody doing this evening? Anybody working on any cool projects right now? Hey, Stephen Poole, how's it going? Welcome on in, my friend. Okay, and with both of these now threaded in there, I am going to go ahead and give it a little bit of an ugga-dugga. That's what we're looking for. Like I said, I don't have the piece up here. I thought I had it printed out, but I am not seeing it sitting right here with the rest of the parts that would go on the tool head. So the best thing I can think of is I didn't print it out because it's not getting used in doing the CPAP. So I think that part might be a little bit different as well. I think this is going to go on and we're not going to use this piece because we are not using the fan, but I might be mistaken as well. We'll see. We'll follow, I don't know, let's follow directions. And I will find that piece, and if I didn't print it, I will get it printed. Cable holders printed, Loctite the bolts at the bottom. Install the top plate to the MGN9 slider. So this is our top plate. And this will be our MGN9 slider. So the top plate, we got to make sure that we do it with the counterboard holes are facing up. That's going to go in just like that. And install the back, front, and bottom plates. So we're going to basically make the cage. We're going to use more of these M3x6 ultra flat screws. So I'm going to go ahead and dump a few more out. We're going to build this cage. And once I get the first couple in here, I will show you something that we need to be aware of. Also, one of the things we need to be aware of is this actually has to be mounted on the printer when we go to do either the top plate or the bottom plate. So I'm going to go ahead and get the top plate started. And we'll have to remember not to do the bottom plate until we put it on the printer, because then that would be bad. There's no way to actually get it on there if you do the top and bottom plate. Repairing Bell's skirt and killing your back in the process. So part of the problem there, Tugboat, is I get where she's coming, is it's a big billowy skirt. So trying to do it on a table, you would need to have a really big like dining room table to do it as well. So I kind of feel where she's coming from there. Once again, now that I have both the top corners in, I can go ahead and add a little torque to this to make sure that these stay there. And actually, I think what I'm going to do is the bottom plate, and then we'll come back and just do the uprights afterward, because I'm looking, this appears to be symmetrical, so it does not really matter which side goes where. And the reason I'm going to go ahead and do the bottom plate is because these will probably have a tendency to twist, so I'm going to need to get both screws going before I try and tighten those down. So we'll get, the whole point is basically you need to have at least one side not fixed so that you can slip this around your rail. Yeah, while it's over the hoop. Okay, yeah, so you've got the, it's like a ball gown, so it's got the big hoop thingamabobber on it. Again, get your Ugga Dugga on. And then something that we're going to have to be cognizant of, okay? These two slits in the vertical uprights, one's high, one's low. On the front, when we add our front pillars, it's the opposite. So in the back, this is high, which means the front needs to be high. This side's low, which means the front pillar is going to need to be low. We've got to remember that when we add in our two front pillars. Okay, I'm going to scoot that off to the side. I'm going to leave my M3x6s up here. Seems to be what we're using the majority of for the print head. All of the rest here are going to go back into the larger bag of M3 material so that we can clean it off the table, because we're going to need to put the printer back up here to insert this part. So we'll get the printer back up here. This is the critical part. So we need to bring this in from behind and get it lined up. Get 4 more of our screws. Nice word there, Dragon. Which one? The hoop? Okay, yeah. Well, we got the picture of you because it was the bell dress that you were wearing in the library that you posted on Maker Millwright's Discord. Did I use a big word, Evil Diesel? Sorry. So the GoFundMe on the Discord is to help Maker Millwright get to Midwest Rep Rap Fest. So Maker Millwright is another maker in the community. Uh-oh. Why is this not up? No, I haven't used that much. So he's another maker in the community. He has finally gotten his visa, but he is disabled. And the way that the the system in Canada works is if we give him like if he gets money in a certain way for certain things, then he can't they'll take his disability. So what's happening is Maker Millwright, the Free Heathen Workshop. There you go, Mr. Wizix. Thank you. Is we have a GoFundMe campaign that's being um, managed by someone here in the States, and that's going to cover his lodging and stuff. But he's got to be very careful. Like he can't come down and like take certain things back with him because it's considered a monetary or in-kind gift, and there's just a bunch of legal restrictions. So we're doing a GoFundMe to cover um, the lodging and like rental car cost. But I think it's lodging and rental car. Bexy can definitely tell you a little bit more about what all it's covered. But yeah, it's as complicated as the day is long. There you go. So with the way the disability, and I don't want to say welfare system, the way that like the medical system in Canada works and the way the disability system works, if he gets money directly, then they basically offset and take all the other money that he gets. And that other money that he gets is, I don't know how he pays for his room and board, place to live, basically. So this is one of the things that we're doing. He was able to get his passport, and he's, lawyers had to be involved the whole 9 yards. So it's just kind of painful. So yeah, don't feel like you need to give. If you can, that's great. But if you can't, that's fine as well. And I know there's other people out in the community that could also use support to get there. So like I'd love to see you guys be able to make it out to that show, but I know that it's cool and stuff and all that. I know. And you got to be careful with these. One of the reasons we're using Loctite and very small short screws is because if you squish these too much and you dig these in too much, like instead of using them 3x6, if you use them 3x8 and then crank them down, you're going to deform the channels that the ball bearings run in, and then you'll have issues. So tighten these down. We want to make sure that there's no wobble on that plate, but make sure it still runs smooth. That's why we're using the Loctite, is so that these screws do not back out. But we don't want to crush the ball bearing races in the carriage, because then we'll cause issues. I got to figure out why my Loctite isn't feeding. Okay, so that's done, and I don't know why I just put that away, because I still need to do the front uprights. This forward so you can see what I'm doing. And we'll bring this back out. Add our front upright. Top. At the bottom. And seal that, because I know myself, it's bad enough if I toss these on the ground, but if I toss that whole bag, it'll be bad. Not sure if these are magnetic or not. That's at least good. They're magnetic. Sometimes you get stainless steel screws and they're not magnetic. And that's bad when you've got small screws and you drop them. because you can't even just go around the floor with a magnet. Okay, so we got to remember, this side, the rear is high, so the front needs to match with the other side. This one's low, so this front left needs to be low. And these aren't going front to back like that. They're going from the sides, because this is going to hold our belt. So that, try and get it lined up on the hole. Through from the bottom. Close, but not tight. Have another one and get going from the top. And that and this stuff is starting to get hard from having it open during builds so much, so maybe needing to order some new Loctite. Then what I'm going to do to make sure that this stays vertical, I'm going to grab a 1, 2, 3 block, just hold it up against the side as I tighten this down, and that should, but did not, prevent that from twisting on me. That was nice. Because your belts are going to be coming in here, you want to make sure that you keep these nice and vertical. Also, we might be using sensorless homing or potentially end stop switches. I believe the option is there for both. So once again, this one is lower, this one is higher. And looking at the way I just did that, I just realized that these slots are not symmetrical between the top and bottom. So I did wind up putting that in the wrong way. Meaning this side goes over here. So we'll have to take these back out. First glance was that these were symmetrical. They are not. But they are not. So the one that is closer to the end, see that? Almost did it. One that is closer to the one of the ends is going to go on this side with that slot facing down. Let's see. Yeah, we'll get them there somehow. You don't think lawyers had to get involved? Well, I think the lawyers had to help him figure out which parts he could get and which parts he couldn't. Like basically, I think he had to talk to the lawyers to figure out what he could get direct donations on and what he couldn't in order to prevent him from losing his stuff. Anyways, we'll get him there somehow. Yep. Find a way to get Get there next year, tugboat. Nice. This year we didn't have enough time to plan. Yeah, yeah. You definitely um, need to kind of plan. So, you know when Rocky Mountain is? Um, Murph is towards the end of June in Goshen, Indiana. 3D Printopia is the end of September, like the September to October last weekend in September to October time. Right? So that's when all three of those are at. And of course, the one in 3D Printopia is in Bel Air, Maryland. Yeah, so if you've got one or two drivers, that works. That means that you can trade off. I'm not going to say do like what me and Evil Diesel did when we drove back from Colorado. Please don't do that. But you know, take some time, drive. You know, drive like a 3-hour stint. When you pull over to get gas, have somebody else drive for a little bit. One, it's cool because the person driving can't really look out and see everything, and you're doing that cross country drive. It's just really awesome. You know, pretty country. Any tools that you need for the Rook. You're going to need a good set of Allen wrenches. If you've got a set of drivers, whether they're things like this from Fabrico or a set of drivers from, say, this one's offset just slightly to one side. That side should be up, according to the CAD drawing that I'm looking at. And I'll verify by just putting it alongside on the other side, and that is correct. So you'll need a set of drivers, whether that's a cheap set of Bond Haas or even just standard Allen wrenches. That'll work. You're just really going to need, like, I'll say standard drivers, M2, M3, M2 and a half drivers. And then some Loctite. You might need 1.5, 2, 2.5, and 3. Because there should be some M5, some M3. You'll have set screws, and those can either be the 1.5 or the 2 millimeter set screw driver requirements. So I would say make sure you've got both of those on hand. Slightly twisted. All righty. So there we go. We've got our carriage on there. That's really nice and very, very lightweight with, you know, printed parts wouldn't be that bad here either, but very lightweight with that CNC part. So comes out very nicely. And once again, I have seen this top plate and that rear running man plate. So the top, bottom, and the rear running man is being carbon fiber as well. Kind of like what you're seeing here is a carbon fiber top plate, bottom plate. Okay, so for the Mellow kit, it needs 4 5mm or 4mm bolts for the MGN 9 block. So I just use the M3x6s. It seems to work, but let me check real fast and see if there are smaller ones in here. So not in the main set of M3 parts. Let me double check that one kind of excess bag. And no, there are not any smaller parts. I just had M3 6 and M3 8. Ooh. Yep. That's what we did is we worked with the M3 by 6s, which were the smallest ones of these flatheads that we did. Once again, that's why we've got the English is hard sometimes. That's why we use the Loctite, and we make sure that we're snug, but we're not like really cranking down on them. Loctite's going to hold, and we don't have any shake, rattle, or roll in it. So we're nice and good. We've got good movement. It's sliding well. We have hex wrenches and all the tools needed for assembling enders. We don't have a lot of things other than that. If you've got the stuff to do an ender, you've got the stuff to do it. Glendon, yeah, I'm looking forward to everybody at Murph as well. Do as we say and not as we do. Yes, evil. Yep. Hey, Darth Gollum, how's it going? You make it out there, you're just going to be a dead English puddle on the floor. No, you won't. No, you won't. Because there's Starbucks. We'll get you Starbucks. We'll get you log cabin coffee, and we'll get you cinnamon rolls. You'll be fine. You'll be on a sugar high. And yeah, so you know, if you've got an electric screwdriver set or a hex driver set, just make sure that it's not really torquey, or that you can drop the torque down. Don't forget Cocoa Press. Oh yeah, yeah, Cocoa Press would be awesome too. Love to have a Cocoa. Mounting the X stop switch, which is optional if you don't use sensorless homing. So you can use sensorless homing, or you can use a physical in-stop switch. I do have physical in-stop switches here. Now I need to find the part. So we did come with physical in-stops. This other metal part that we have here, I believe, is for this purpose. If not, I do have does not look like be the part that would mount there. So this would be for a different mount. Most likely the Y end stop, because we've got the D end stop back here. Once again, we'll have to solder our wires for that. We'll have an X end stop here. Now the way that end stop goes is it's going to be mounted like, whoops. I just sent. It'll be mounted rather than just sitting in there the way it is. Kind of like this on that rail. I've got to figure out how much or how far it will stick out, because one of the downsides there is these actual poles, and then you're going to have to put wire on them. So it might get iffy. We might just run sensorless homing on X. And then we'll see if we want to do Y as well. But for now, I'm not going to install it, simply because I'll say I'm a little worried. I believe I do have that part printed out, but I am a little bit worried of whether or not that's going to hit anything and cause us a problem. Especially from a electrical standpoint, because once again, this is an aluminum plate. We're going to have to be careful with how we route wires around here because it will be conductive. So hold off on that. Also, you can use the V-Core original X switch with this mount. Next, install the rear adjustable fan mount. And there's your little carbon fiber running man. That's the bomb needed to mount the in stop. Like I said, we may come back and do that a little bit later. Do I have the printed part? Like, I feel like I printed parts and I'm missing like an entire baggie. I am missing an entire bag. Where did I put the entire bag? It was a larger bag because it had panel parts. Where did I put that bag? Oh, it'd be this bag right here that. So these are going to be parts for the fume extractor that'll come off the back. Well, that one came. This will be the fume extractor that'll come off the back. Then here were some other parts, and I thought I had tossed the extra things on here. They're going to be printed in a darker color. Oh, that's the PTFE tube. Okay, so I'm not seeing it. So apparently I decided not to print it, or if I printed it, it's somewhere mythical, meaning not where my brain thought it was at. Or it's on a plate that I thought I had printed and I hadn't yet. I'll look for that later. They said we can add that later, even if I've got to pop something off to put something back on. But our running man, so we're looking at this from the rear. And I'll say our upper leg and lower arm goes to the side that's lower. So let me, I'm going to turn this around some. So this is our higher belt path. This is the lower belt path. So our running man will go on there like this. Well, two screws through here with nuts. And these are going to be M3x8 low profile. Or M2x6 for the new version of the mount that has a groove for the M3 nuts. And of course it has a groove for the M3 nuts, which means I put this on backwards. That sucks. Good news is I just need to take the top and bottom screws off of one side to take it off. I got to turn this around. Apparently I didn't either read the instructions right or the instructions showed a flat edge, because it sounds like newer versions of this didn't have this routed out channel for the nuts to sit in. Issue is needing to turn this upright 180. Need to pop these off, turn the upright 180 back on. The black box is coming along. It's sitting over there on the corner. It's still sitting right there. One of the things that I need to do is straighten the piano wire or the spring steel wire, and I'm going to do that for like 4 of them, and then I'll do one on stream just to show it how, show everybody how it was done. But you have to like use a vise and the drill and everything to do it. So I'm going to try and do it downstairs, then maybe bring the vise up here and do one on stream, unless it's really worrisome, because you are straightening out a spring steel wire. Means it could be a little bit dangerous. So I want to be careful of that. That's now tightened back up there, and so this channel will be where the M3 nuts fall in. That'll make it a little bit easier to tighten, so you won't have to like hold on with a pair of pliers on one side while you're tightening. Should easily line up, and we'll put our screws back in. So thanks for the lurk, Tugboat. Yeah, so Chris has been around a little bit. He's popped into a few streams lately, but he's been, I mean, they've been moving their shop, and so they've been dealing with trying to get all their equipment set back up, and as well as getting orders pushed out, because some of the stuff they cut in-house, like their panels and sorry, some of their CNC parts, they're cutting in-house now. So it's just a matter of time. Like, he's literally popped into the stream while he is driving home and listen in while he's been driving home. And then when he gets home, he's got a little one. So, but normally we'll see Chris too in here. Okay, so we got that squared away again. Okay. Bexy's going to work on getting her back relief by jumping into bed and letting some back muscles relax from being knelt over on the floor. Okay, so we've got our M3x6s, we're going to grab a couple of our M3 nuts. Not sure if we necessarily require any Loctite on this, but I will, since everything's metal on this, I will put a little bit just on the end threads, just to make sure that nothing vibrates and backs off. And once again, we're going to go through the machined holes at the top of this, through the slot, and we're going to hold our nut in the slot. It should fall down in there and be captive, which will also keep the nut itself from turning in the slot because it's machined well. That's nice. Yes, this is, and it's like been janked up and the stuff has been crapped out, but it is a Loctite glue stick. It is literally, I think, Loctite stick. Make sure you get the blue. If you get the red, it's probably not ever coming apart again. Especially on these small screws, you will strip these screws if you use the red. Not going to ugga-dugga this down all the way. I'll do one just to keep it from moving up and down. But the nice thing with this is there's a lot of play. So if you do like a super volcano, like if I put the Tocado on here, you know, with a super volcano, I'm going to have a lot longer, so I can drop this down a lot lower to account for that longer hot end. So you can get the stick, or you can just use standard Loctite thread locker. This is the blue 242, which is removable. That's what you want. So this is the liquid. If you're going to use this, I would say realize I was out of these. I tend to just grab some of these. These are lids to little like condiment containers. Get these off of Amazon really cheap for like a couple of hundred of them, or the containers themselves. You can either use the containers or you can use these. I use these for Loctite. I use these for mixing epoxy on. You know, you can, whatever. But you can use standard Loctite or the Loctite glue stick. Excuse me. So we've got our running man attached now. And now it tells us to install the belts. Make sure your motor mounts are at the lowest tension possible first. So that means basically move your motor mounts all the way to the back, or your front motors all the way to the back, push them physically to the back. And you're going to start at the front and insert the belt through the side slot and loop the belt on itself. This is at the front of the first video. So we're going to start at the front and work our way around the belt system. So before I start belting, I'm going to ask you to give me 1 second. I'm going to mute the mic because I need to blow my nose real fast. So let me do that. Be right back. Okay, I'm back. I'm also going to cheat and grab a Hershey's Kiss while I'm. Yes, I was at Murph 2023, and I did have a table set up over by KB3D Chris for the KB3D booth, and we had the we had the 0G Mercury 1 there. This is a custom build. In fact, I have a touchscreen panel. I just take it off when I transport it. I don't necessarily need it to print day to day here because I can do it through the web interface, but it's always nice to have a clipper screen at the shows. It's just a lot easier to be able to click on the front, especially if I have things at different tables. But this and the Rook 2020 was at their table. Yes, all the machines. So this one, the K3 and Black Box are definitely going to Murph. The Rook 2020 that I'm going to rebuild or build with the new parts that are printing right now over here out of the electric pineapple will be going, that's going to Murph as well. And then there will be some printers that will go to Murph that will find new homes. So you were at Murph last year? Okay, so do you remember where KB3D's booth? KB3D, when you come in through the main entrance, they were on the left side about 3/4 of the way down on the inside of the outer row. We were right behind them in the center rows. And like I said, I had two printers over on their table, and I had a Prusa Mini there because that was for I was bringing it for Westery 1 because she had sent it to me. I fixed it, was bringing it back. I think Cookie Cat, yeah, because I think Cookie Cat was in that far back left corner, wasn't it? With they were over there next to Alien 3D, I think. So yeah, we were there. Oh, you were talking about Rocky Mountain. I'm sorry. Oh yeah, that was for Murph. So at Rocky Mountain, I was right behind the KB3D booth. So you had Boron, Fabrico, West 3D, KB3D, and then we were right. We were the second table down, so you had Edge of 3D, us, and our backs were to the Bot Rumble guys. So the BattleBot Arena. We were right. We were between the BattleBot Arena and KB3D's booth. Yeah, no, I came over and talked to you at your booth. And then we also went over and talked at KB3D's. Because I brought you over to KB3D's booth and we looked at the Rook there. But you guys came over a couple of times and looked at my booth because I had the Annex K3, the Micron, and the Salad Fork were there. And then, yeah. Yeah, I came over and looked. You guys had the two enders. You were on Sunday. You had gotten a Micro Swiss NG extruder, so you were tearing one of those down. Yeah, we were. Or I'm sorry. I was talking about Rocky Mountain this year. I was at Rocky Mountain 2023. I was walking the floor. I did not have a booth at the inaugural Rocky Mountain 20. I'm sorry, that is my. I was at Rocky Mountain 2023. They only had the one side, the North Hall. I did not have a booth. I was walking. I was walking. So my bad. So anyhow, we're on to belts. There's a couple of different ways to mount the belts. So make sure your motor mounts are at the lowest tension possible first, which is where we're at. Okay, sounds great. Yeah, I may have walked, I'm sure I walked by and saw you. That show was such a blur because it was so incredibly crowded. I was so glad that they got the two sides of the venue, but at the same time, it felt like we had, well, didn't feel like we had more people there this year than last year. But because we were spread out, it didn't feel as crowded. Yeah. So we're going to start at the front and loop it through the side slot and loop the belt on itself. We're going to insert a piece of filament that's at least 6 millimeters into the loop and then slowly pull it back. The alternative is to use a belt clip, but when we're coming over here, there's not going to be very much room here. So really what we're going to do is grab the belts here. Okay. All right. So we're going to take and loop the belt on itself like that. And then we're going to put a little piece of filament through the middle and pull this through. And that filament's going to squish that outer edge just enough that it's going to get clamped in this slot on the side. Make sense? And because these are lining up with teeth, let me understand belt pattern. There be teeth there versus, oh my God. So these rails need to be flipped the other way. So the whatchamacallit, I'm gonna have to take the rollers off and switch them around. So I've got teeth on the front, but it should be smooth idlers here on the front because teeth come around the front motor pulley. The belt's gonna come down and go around this pulley and come across, which means this should be the back side of the belt, which should be on a smooth pulley versus a tooth pulley. So I basically need to, the easiest way to do it right now is going to take these bearing stacks out and swap them around. So in essence, and I dropped my belt everywhere. Oh, that sucks. Oh well. So this is a tooth pulley down here and a smooth pulley in the back. It needs to be a smooth pulley down here and a tooth pulley in the back. So in essence, I need to take these two mounts and flip them side to side. So we're going to take these, we're going to take this and this one out, swap them, and then we'll do the other two. Kind of stinks, but good to catch that now versus later. So we're going to need our pliers so that we can hold our lock nut. while we undo the screw. Go ahead and do the one back here as well, because like I said, I'm going to swap the basically the front and back on each side. Because that way the pulley stacks are in the same way. Now the downside is there's going to be a spacer, the pulley, and then on top of the pulley, between the pulley and the top of this plate is going to be a spacer or a little washer. So let me see if I can't get you a camera angle. Like looking straight at me. So this so this should be a spacer, a pulley, and then there should be between this top plate and the pulley, there should be a washer. So we're going to need to pull this stack out and then swap it around for the tooth pulley on the other side. Try and stick that stack back in and then get everything lined up. And it may be easier to crack all of these so that the tension, of the bracket itself is slightly less, because there is a good amount of tension here. I don't want to take them all the way off, but I want to crack the bolts just enough to release the tension. But I have to do it on all of them to include the ones going through the gantry. I don't want to take them out or off. I just want to crack them to loosen them. And that will allow me to get a little bit more room as I'm trying to pull these out and put them back in. Hopefully frustrate me a little less and make it a little bit easier. Once again, we got a spacer, the pulley, and that tiny washer which acts as it. Whoops. So spacer, pulley, and a tiny washer. This going to act as a spacer on the top of the pulley to keep it from pressing. Back side is going to be once again high. take a slight bit to get things lined up. Be afraid to use a long tool like one of your drivers to work things into place, just like that. That should allow us to get our shoulder bolt back in there. Go. Now we're going to work on this side. Once again, this is going to be the same way, so it's going to be high on this side. So we'll go the spacer at the bottom, fully on top, with that little washer at the top of that. Slow, take your time, work on getting things lined up or not. Okay. Now you guys are over there looking at the fiddling. Things in the right alignment is apparently going to be a little bit harder on those. Probably because of the way I'm working my fingers. Fairly tight stack, so you have to try and get things lined up straight. Might be able to get a little bit of an angle, but not going to be much. At least got one on top of the other. Now it's about just getting enough alignment that we can run our screwdriver down the center, get everything lined up again. Then you get your screwdriver down there and you can just circle it around. That will line things up enough that your shoulder bolt will be able to go through fairly easily. Go. So that's in. Now what I'm going to do is I'm just going to go ahead and put the nuts on the bottom finger tight, which means they still won't be too tight to prevent the little bit of slack in there when we go to take the other sets out, but it's also not going to be tight enough or loose that will drop things. Do the same thing that we did before. We're going to just do it on the front right, back left. Swap these pulleys around so that we have our smooth pulleys in the front, our tooth pulleys in the back. Be aware that your washer is on the bottom here, so make sure you have your hand underneath it when you go to pull the bearing stack out. You don't want to lose that washer. Same thing, we're going to make sure that that washer is kind of lined up on the bearing. Washer is lined up on the spacer pushed in. Use our screwdriver to get everything lined up. Brought into alignment. Shoulder bolt in there. Careful. Go. Now on to the other side. It'll be a little bit harder for me from this direction. Got the first washer. Bearing. Need the spacer. That bearing place as I get this larger spacer. Here. Go. Our inner screwdriver to get everything in alignment. And I just felt my bottom washer fell out. So we're going to start this process again. See if I can't get it shoved in there. Too hard. Okay. Shoulder bolts through there. And add our locking nuts. Finger tight. And then we'll come back in and tighten everything down. Hey, Hobby Main, how's it going? Welcome in. We are in the process of, well, we were gonna do our belts. We started off having to go through and add Loctite to all the grub screws on our 4 motors, and then we built our tool head, or at least the mount for our tool head here. Had to take some of that apart and redo it because we put a part in backwards. And now what we're having to do is go through and swap our pulleys from side to side, because we had the tooth pulleys in the front and the smooth pulleys in the back, and they needed to be the other way around. So what that amounts to is when I mounted the Y rails and decided to pick which side was the front and which side was the back of the printer, I chose poorly. That's basically what that means. Now what I'm trying to do is just tighten up everything back on the XY gantry so that we can proceed with the belting operation. Okay. Ugga-duggas have been ugga-dugged. I'm going to make sure that my rail bottoms out, same place front to back. Front doesn't bottom out the same place, but that is because they're bottoming out. One's bottoming out on plastic, and the other is not lined up with the plastic, but it's lined up with the actual metal mount. So good there. Still a little bit of play there. That's their play. It's not tightened down. Tells me something's not tightened down. So hey, back at you guys. Okay. Good to go. Things still flowing right. I'm going to switch the cameras back around. Bring that one back out a little bit later if we need to. Okay, we were belting. I dropped my belt. Plan. It's easier if we don't have it all loose, but so be it. Wants us to talk about doing this one first. So what we're going to do is, knowing the way we go around our front here, I'm actually going to at least go around the front pulley. Around the front pulley, around front lower pulley. Then we're going to come this way. So once again, we're going to go through our sleeve, twist it in on itself, line our teeth up. We'll need to put a little bit of filament through there. So what we need is some filament. We'll need about 6 millimeters, and we're going to need something that's high temp resistant, like, I don't know, some polycarbonate carbon fiber maybe. That'll work. And basically it needs to be longer than the slot there. So that's about 6 millimeters. So we'll take a quick measure, cut off a piece that's about 6 millimeters long. Which isn't that much, right? These are 6 millimeter GT2 belts. So once again, we're going to rotate our sleeve or our belt around. We're going to slide that little piece of filament right down into the gap. We're going to push the belt back through the slot. Basically, the filament is going to enable us to capture the belt in that machine slot. And I'll bring you guys in closer to show you this. So we pulled the belt in, wrapped it around itself, put in a little piece of filament, and then pulled that belt back through. So you can see there's only like 2 teeth. But since these teeth are interlocked with each other, this is just enough to expand this part of the belt out so that it gets caught in that gap and it won't pull out. That's a really, really ingenious way of doing it. And it keeps you from having to use like belt clips and zip ties and all these other things that really just gets in the way of routing your belts cleanly, and enabling like your tool head to go all the way to the end. Now, your belts also need to go through right in front of your side carriages here. So you might need help them along because this end was really had a good twist on it. So you might have to use a driver or something, or a pair of tweezers. Keep your belt straight as you go through between the XY gantry and the piece. Maybe we'll come back. Try this. Yeah, so what I was doing was trying to run this between the XY gantry and the carriage itself here. That's where this belt's coming. Okay. Now I'm going to go ahead and pull this through, get all the excess slack out. Now the downside is they're not giving us like a certain amount of belt length. And they did caution of do not like just cut it in half, because you may not have enough belt length to go fully around. So on our belt path, which not sure if they actually have the, no, they don't show the belt path here. So let me switch view. So at this right corner, rather than go around, the motor pulley, we're going around the tooth pulley here, and then it'll go around the tooth pulley on this motor. So that's kind of how we're routing it, so that the opposing corners are actually the motors that are working together. So this will be fun, trying to get this around the corner. There is really no good angle here to try and show this. All I can really do is hope and pray that I'm not inducing a twist in this belt at this point. Nope, we're still straight so far. Okay. On the left side, we go in front of the smooth pulley and then around the motor pulley. Front of the smooth pulley, around the motor pulley. And of course, make sure that the belts are lining up on the idler teeth. And the final around is through this tooth pulley. Need to get it looped around there. Pull the slack through. Sure that we get around the pulley. And that's where we're at. Now, in both, or in the best of both worlds, we get to use language. In the best of both worlds, I would figure out where this is. I would cut it. I would take this belt back off, and I would try and make everything match as far as the number of teeth, and then reroute all the belts. So that's probably still what I'm going to do. Just kind of sucks, but I will run this long, probably to the other side here. Pull it a little tight. And that's where I'm going to cut this belt, and then hope and pray that I've got enough cable or belt length to make these match tooth for tooth. The same process, and then we'll reroute the belt. And if we're short, I'm pretty sure I've got other GT2 belt around here. So pull this out. We're going to pull this back through. All the way back through. Means we're also going to pull this bit out. Make sure that we keep our little piece of filament there, and then we're going to match these tooth for tooth. So how does that mean we're going to do it? Well, that means this is the belt that I just ran. So that's our length of belt. I'm going to take this other belt, one that I ran for length, goes on top of this end. Now I make the tooth align. So I make the teeth match up. That way, as I pull these together, when I get to the end, I just need to cut the remaining belt at the first length that appears beneath the belt that we ran the first time around. And that will give us two equidistant belts, which makes the initial tensioning a lot easier to do. How's it going, zombie? This is the VzBot. This is the VzBot. So there's our excess belt, and just a quick glance. It's nowhere near long enough, so we very well could have cut this in half, but we would have had probably a rook's length of belt that, you know, that's easily going to be good for a rook. If you do this, one, it makes it easier because you count the number of teeth, and you'll get the initial tension set for your belts the same. Then when you make your adjustments, it's a lot easier to get the belt tension set the same on both sides. Ooh, some pad thai chicken. That sounds good, Pez Liz. All right, have a good one, Tugboat. See you around. Hey, Jedi Spidey, how's it going? Jedi Spidey is another somebody who lives in North Carolina at the moment. Not sure if he's truly North Carolinian because he's lived here for long enough, or his whole life, or what, but he is currently a North Carolinian by location. What I'm doing is I'm just going to cut a couple of pieces of filament to roughly 6 millimeters based on the first one that I cut. And the filament that I'm using this is some leftover PC carbon fiber. So it should be perfectly fine uh, for this use case, which is holding our belts together. Now, once again, make sure that the words on your belt are upright when you run them. I don't know, it's just something I heard that you got to make sure that they're always in the upright position. And what I'm going to do is I'm just going to start from the back, knowing that I need to go around this pulley here. Or yeah, the pulley, not the motor pulley, but the standard tooth pulley. Just going to pull that around that tooth pulley. Pull it forward some. Now we're going to go between the rail here and the carriage. Bada bing, bada boom. Now we're going to go around this front motor. So the nice thing is with the way the parts are printed, it kind of forces the belt to go around the loop, and then you can use your finger to continue to get it to follow around the motor pulley back out. So a little bit easier to do, especially if you don't have the front panels on that I haven't put on yet. Now we've got a smooth idler at the front. We're just going to bend our belt around a little bit to make it a little bit easier to get around that smooth idler. We'll pull it through some. Now's where we go through the belt, and once again, we're just going to fold the belt over on itself with a couple of teeth. We'll insert the piece of filament into the belt, and then we'll pull it back through the slot, and that's going to hold this in place. So get 2 or 3 teeth engaged on themselves. Take a little piece of filament and put it in the folded over edge. Where the teeth are engaged, pull it back through that slot. The teeth engaged, it should be enough that the belt will come back through the slot, and just pull it tight, and that will give you let me see here. What that's going to do is give you 1 or 2 teeth that are coming out the other side that are engaged. And that's going to prevent this belt from being able to pull out once you tension things, because it's going to pull in on that bulged piece of belt with the filament sticking through. So that is your belt clamp. So you don't have to do a clamp on this side or a zip tie or anything like that. This makes that clamp right through there. Now, I went very small on the number of teeth that I pulled through, and that's because if I'm using sensorless homing, if I do too much, it may foul on the pulley over here. So I didn't want a whole bunch of teeth, but I will have enough that if I needed to and I wanted to, I can go 1 tooth more or something and not have to worry about it pulling out. Now, once again, our belt path comes around through a smooth pulley. So the back side of the belt across the smooth pulley over here. Come forward around the front idler pulley, or not idler, but motor pulley. Through the side, around a tooth pulley at the back. We're going to come over here with the back side of the belt on the smooth pulley and route our belt around the motor. Okay. Bring that belt back through. We're going around this motor. We're going to go around this other tooth pulley. And then we'll do the same thing back here on the back side. I'm going to hold off on that for just a moment until I get the other belt run. I'm going to kind of do the same thing. I'm going to start with my belt back here. I'm going to go around. Yeah, tooth pulley over here. Need to go around the tooth pulley. Around you roll your belt over some to help it take that form. Make it a little bit easier to get it around your pulley. Hard part here is just that we've got the linear rail in the way. Kind of like trying to get it around the pulley and out of the way of the rail. Now we're going to go once again between the carriage and the linear rail carriage. Come up to the front, go around that front pulley. Forward. Now we got to go around a smooth pulley with the back side of the belt. Then we're going to do our little folded over end once we get it through the carriage. Fold over the end a little bit. Put in our small piece of filament. Throw said small piece of filament onto the black surface, which makes it 20 times more difficult to find. That didn't work. And drop my piece. So this is the slightly fiddly part. There are, like I said, printed clamps. You could use there's a printed clamp. There's a you can use a zip tie. The whole point here is to try and use minimal stuff to be able to hold this belt in place just like that. Around at the top, so we go smooth belt down the pulley. this top pulley. And now we're ready to try and tighten some things up and keep things one in line, and then two. Retention some things. Sure that everything lines up their respective locations. And then what I'm going to do is I'm going to switch camera view, and I'm going to turn this around. And we'll get the belts initially lined up. And if memory serves me right, for some odd reason, I only printed one of the belt clamps they suggest using on the back side. It's probably going to be easy to either raise or lower this or take it off completely when we go to get these in here. But we can do the same thing here, which is bring the belt through the slot. Not the same thing here, but we're going to bring the belt through the back slot. And rather than pull it back in on itself like we did before, this is where we'd want to use the clip or a zip tie up on our pulley. Pulley that pulley. Okay. This is where we'd want to use a belt clip. Now we've got a two-piece printed belt clip that of course I didn't take out. And I'm not sure how this works. Sometimes I get these printed decently, other times not so well. Two-part printed belt clip. Sure. Exactly it works or goes in, so would probably be a great thing is to understand how the darn thing works. Ah. Sorry, folks. Doesn't make sense. That's the belt path. There's the comment there about using the piece of filament. Belt tensioning. Running an in-stop switch, but it doesn't actually show you video for the optional two-piece clips. They are here. See if this video will open. We'll see about what's the best way to do this. Oh, of course, we've got ads, and more ads. Yeah, see, he's got the front pieces of acrylic in place, and I haven't done that just yet. Just because I think getting the belts physically routed would be an easier first step. Try and move forward just a little bit. So here you go. Here's a little bit better view of how you're going to put the filament in. We're just going to try and go till we get to the doing the back. Yep. Hey, Da Vinci, welcome in. Hobby Main, welcome in. Just trying to make sure that we know how to do the belts here. Not sure if the desktop audio is coming through for you guys or not. If it is, could somebody give me a thumbs up on chat? Actually, it'd probably help if I do this so you can see what he's doing. Interesting. As you come through the front, round the back, This is the clip that I printed out. Okay. Okay. So, so with that, I've got the part one of my clip has the hole through the middle, and it's got the little slot that's going to allow the other piece to clip in and hold. So I'm going to slide this through the flat side through the belt. Just get that on there. The belt, the flat side of the belt goes through so that the teeth will be facing the gantry. Pull that somewhat tightish. And then this piece will go on, but you got to be careful because this piece has little nubs printed on it. That nub needs to be facing that part that you slid on. There's grooves in there that will fit around the grooves of the teeth or the grooves of the belt. So you're just going to kind of get this somewhat close and fiddly. Probably because I've got the bed up so high. But make sure that the belts are on all of our pulleys right. Try and get this as close to the back of our printed part as possible. Get it to slip over both belt parts. Like I said, I'm probably trying to get, quote unquote, a lot of pre-tension on this where it doesn't need it. Get the teeth lined up. You should be able to get this on there, both sides, and then just push the clip over it. This might be, we're using our forceps just to, not to hold it tight, but to get a spot where it's tight. Excuse me. just to squish our belts together. Once again, we want to make sure that the teeth are kind of lined up. That way, doing that, as long as we've got belt sort of tight. Where's the other piece that I just sat down to do that? There. This might help us be able to get this on there easier, because our belt is going to be somewhat squished together. Or maybe not. Pretty tight belt clip. I don't know if it's just my print settings. I'm going to see if I can't wedge it a little bit. I hate belt clips anyhow. So, somewhat super fiddly. And quite honestly, I like the other way that we were doing it, so I might just do it that way. We can either attempt to do the belt clip the same way as we did on the front, or we could always loop it around on itself and use a zip tie. It's just really, one, I don't know why you would come in, go all the way around and come back. That to me is, other than, hey, it provides a really good amount of excess loop if you ever have to do like repairs. But to me, it's just a whole lot of excess belt. And I probably don't need this clip piece on here now. I've decided to go away from that clip. So we can either try and feed this back in on itself like we did the other one, or what might be easier is just to bring it around like that and do the standard zip tie method, which I kind of like. It's not as eloquent for some people, but it has proven itself as a viable method. You make sure that you get your belt through there. I'm going to kind of give myself a little bit of tightness before I do the zip tie. I'm going to try and get that zip tie as close to the metal edge as possible. Probably should have made sure that I had an equal gap on each side, but I didn't. Other thing I'm going to want to do is get this moved all the way to the front. Make sure that our belts are properly on all the pulleys again. Forceps are nice because it gives you something to hold your belt while you're trying to get zip ties started or going or what have you. Once again, I know this is not the prescribed or recommended way for this particular build, but this is what I'm going to do because, quite honestly, I'm done playing around with, pick a belt clip and hope and pray that print settings are just right so your belt clips work without a hitch. Flip that one and redo it from a slightly different direction. This way the heads of my zip ties are, I'll say, on the inside edge, so they shouldn't foul on the on the pulleys. We've got plenty of excess length here. All of our belts are running true on our pulleys. So we're good there. Sorry about that. Okay, so we'll come here, we'll look. Next up is step 5.1, take a rum shot. So apparently we're supposed to be taking a rum shot. We go back over to Chrome. So once again, we've got our belt pass run. We did not do this loop it all the way around and then come back. I may have had just enough room, but yeah. I don't know why you would ever do that. Toolhead is there. We've got, if anything, I may have my belts really tight. So I'll have to check the belt tension. And if need be, we'll loosen each side up a little bit, and that way we'll be able to tension them properly. So if you get too much preload on your belts, then they're too tight and they're already tighter than they need to be, and you're just causing additional wear. If you're too loose, then you run out of adjustment, but there should be plenty of adjustment on these motors. Now, the one thing that I want to do, because it immediately starts talking about adding the fan duct and your extruder hot end combo. Before I do that, I want to actually sync the belts. Because I want to make sure that our belts are properly synced for the all-wheel drive setup. Especially before I start putting panels on the thing and it becomes difficult. It's important the rear motor pulleys are attached without grub screws spaced in the flat part of the shaft. One can also use a motor with a round shaft instead of a D-shaped shaft. Before tightening, one needs to loosen the set screws on both the rear motor pulleys. Get a proper reading of the tension. After tensioning, you will need to power on the motors so they are engaged. Thus, on a step position, you will now tighten the grub screws again, making sure the screws are not on the flat side of the shaft. Turn the motor shaft if needed. Wow, so if we need to have the motors engaged, there's no way of doing that unless we like bring up a test stand or something like that. So we might have to do that after everything to get our belts tensioned properly. Or excuse me, not tensioned, but synchronized. So, okay, so I guess we will pop back over here and continue on installing the fan ducts and so on and so forth. So there's two different things that we can do here. We can do fan duct or we can do CPAP. Well, I say fan duct. I mean, we can do a fan, as in a 50-15 fan, or a CPAP. This kit comes equipped for CPAP. So everything that we do as far as the fan height adjustment and stuff is going to be the same. It's just whether or not we're using a quote unquote fan or the actual CPAP. So let me clean up all the parts that I threw out here on the table. Mount this either right now. So we've got our fan duct that would go through the back, and we have, or excuse me, we've got our tri-horn for the nozzle, and then we've got the bracket for our hose. So these are going to be mounted through the lower portion of the fan holder. We'll be able to adjust this up or down once we get our tool head installed. Need to put in some M3 nuts in here, and we'll need some M3 by 10 bolts. That'll be the button heads. We'll grab some M3 nuts. two of those. Need M3 by 10 button heads. M3 by 10. There are some, I'll say, depressions. They're not, I don't think these will fully seat, but there will be depressions that your M3 hex nuts will drop into. Kind of squeeze those in place. And your tri-horn aims down. So you want your flow aiming down, not up. I'm going to take one of these and put it through one side. Grab the size driver for that. Lined up. I'm going to pull this further forward so that I can get straight on with my driver here. These up. Now I have printed everything here out in ABS. You could potentially print it out in like polycarbonate or nylon, something else that's going to be higher temp resistant. So just be, cognizant of that and aware of that. Now it talks about installing your favorite extruder hot end combo. Not sure in which order these two things get mounted. I believe the extruder gets mounted first, and then the Goliath gets, yeah, so this will get mounted to the top of Goliath, and then the plate, these two holes on the, so Goliath gets mounted using the 6 holes around the PTFE guide, right? And then these 2 holes get screwed from the bottom up into this plate. So we can mount our extruder first and then mount Goliath. Now, the question is does it tell us how much PTFE tube we need for Goliath? And by the way, I do have the tri-horn printed, and the version does not have a brace on it. I need to figure out, because there should be a tri-horn duct that allows the use of beacon, because that's what I want to do is use beacon with my Goliath hot ends. So I think we need to pull up Goliath as well. Back here we go to Goliath. That's the go to the configuration sections above. There are links down below for instructions on the BOM. We're going to do direct drive setup. I'm going to use the Vz-Hextrudort. Mount from the bottom with the same holes as LGX Lite. Okay. Two M3x8 ultra low profiles will come in from the bottom, and we'll mount that at on the tool head. So I'll flip this around. Where's our Vz-Hextrudort? Right there. Here's the bottom of our Vz-Hextrudort. It does look like there will be PTFE tube that goes from here down into the Goliath. I am hoping uses a cycloidal gearing. It looks like there will be PTFE tube that will go from this through this and into the top of Goliath. So that's going to be interesting. We're going to need M3x8, the ultra low screws, aka the flathead screws. Not countersunk flatheads, but the ultra low flathead screws. We're going metal to metal to metal, so we are going to use some locktite. We're going to come up from the bottom to the top. This will be fun. Loctite on our screw. Drop our screw. Not know where our screw went. All right, so sorry folks, but you're gonna get a big fat dragon head. Here's one. Hey, Westry, how's it going, sis? Welcome on in. We are putting together our VzBot 235. We had to fix a couple of things on our gantry because our pulleys were in the wrong spot. And then we needed to, once we got that figured out, then it was maybe that's not the right hole. Where's Bexy Beans to say that's what she said? That's the There's our Vz-Hextrudort installed. It installs with just two M3x8 low profile screws. A bing bada boom. Rec drive. No other information there about any PTFE length. So Goliath docks, let's go over to the instructions. Goliath is using a nichrome wire to heat up the block. It is quite stiff, but also bendable to the desired position. Be extremely careful when bending. Be gentle and take your time. Put your thumb where the nichrome wire exits the heat block to hold it in place and avoid the wire going out of the groove. And also protect it from bending again if the portion that was bent already. And slowly bend it to the desired shape. There are 3 positions that can be used for the heat block. Since there are 3 screws / standoffs, so you can rotate the heat block to your need. On the VZ print head, you can either send the nichrome wire to the back under the print head, or send it to the right or left in the front. Sending to the right will keep the natural bend of the wire. It's recommended to add some thermal paste or grease between the heat break and heat sink for better heat transfer. Not use boron nitride as it will dry, make it really hard to remove the heat break from the Add a heat insulation sleeve if you like to give more protection of the nichrome wire that sticks out. You run the Vz-Hextrudort CNC version with the VZ print head, which is what we are. Here we go. The PTFE tube between Goliath and the Hextrudort should be 22 millimeters long. 22 millimeters long. Getting ready to crash for the night. Wanted to stop by and say hi. Well, thank you for stopping in and saying hi, sis. I know you've been really, really busy. Real quick before you head off, though, did you say that the construction workers stopped working on the house? I thought that's what I heard at your last stream. I'm just trying to make sure that I heard right. Um, yes, you did. Uh-oh. Well, that's not good. That's not good. So this is the part that just stinks in. And we might do this over on Thursday because it's 9:30. We may see what else we can do, but I don't want to keep pressing too much because this might be a fiddly piece right here. Because here's the thing. There's our PT or our PT1000 thermistor. Right? This gets screwed into the side. Here's our Goliath with a package of thermal grease. And what appears to be a fully built hotend, but with the way they're talking and the instructions, like I don't know if like all of this is ready to go, if like the heat break was properly done with thermal grease and the thermal grease that's included is just for oh crap, I need to swap a nozzle and do a you know what I mean? So I don't know if the heat break here has been properly done with thermal grease already in these kits. I do like the idea of it coming out the right side. So this will get mounted in this direction, which you can tell our fan needs to come like way down. because our nozzle's not even installed yet, and this isn't mounted to its plate yet. It's I kind of want to watch the rest of Steve and ModBot stream, and maybe even look at what's his name, Nero's stream on his 330 build to see if they actually took the heat break or the heat sink off, took the heat break out and redid it, or if they assume that this came pre-built since all the wiring is done really nice with heat shrink tubing and all of this goodness. Or if theirs looks completely different from this, and this may be an update based on feedback, so you don't have to go through and do all of this. You know what I mean? Because this has, I'm assuming, proper high temp sleeving and stuff. Whether or not you want to put any additional around here, like Kapton tape or something, I don't know. Yeah, like I don't know if this is considered a pre-assembled Goliath, and the instructions are assuming that you just got a standard Goliath, and that you had to or that you have to assemble it to this stage. I don't know. So for those of you that have been gone and dealing with an ad, so this is the Goliath, and what I'm questioning is the cooling block is already pre-installed here. So I don't know if I should take these screws out, remove this, take the heat break out, and do anything to the heat break, or if I should assume that there's already thermal grease on the heat break because of the way it's assembled. Because this is really nice wiring, it's been really done, it looks properly finished all the way around. Should my assumption be that this is a factory finish to this point, I just need to add my nozzle of choice and mount it in the printer. So what I want to do is I want to look at Steve Builds and ModBot stream, because they streamed a build together, as well as Nero's stream because he did a 330 build, and see if it came this way or if they redid theirs. I don't know if this is considered good to go, or if I need to take this apart and do things. I do know that it says we need 22 millimeters of PTFE tube, because the PTFE tube does go way down in there, as well as it needs to go through 2 aluminum plates and into the gap that's at the bottom of the Hextrudort. So we're definitely going to have to put in the 22 millimeters of PTFE tube. And I am going to follow this where we bring it through the right side of the mount, or around the right side of the mount and up back. So they have to measure the ceilings to make sure that the ceilings and roof isn't caving. Where the chimneys were, there are boards that are jutting out and not wanting to go back in place. I'm surprised they're not tearing enough of that wall back to see if there's any damage to that particular wall. But yeah, because this comes with thermal grease, right? So let me read through this again. Recommended to add some thermal grease between the heat break and the heat sink for better heat transfer. not use boron nitride. You can add a heat insulation sleeve if you like to give more protection to the nichrome wire that sticks out. If you run the Vz-Hextrudort print head, the PTFE tube be 22 millimeters long. Make sure everything is tightened properly, and once you have it mounted and ready, do 2 to 3 heat cycles, then tighten the nozzle to between 1.2 and 1.4 Newton meters. So you do need to get it properly and securely mounted. Heat, do a thermal cycle 2 or 3 times. Keep it hot and hot tighten the nozzle for the last time. Same applies for heat break. To remove the heat break, you will have to heat the hot end first to melt the plastic inside. This can be challenging. Wear protective gloves to avoid burning yourself. Hopefully we don't have to ever do that. Remove the hot end from the print head. Remove the PT1000 sensor. Remove the stock. Unscrew the 3 M2 screws to remove the heat sink. Once the heat sink is removed, brake is accessible. Gun or blowtorch to heat around and make sure you get everything cleaned out. Right side, this is back. Yeah, see the Mellow kit looks like it's a little bit more finished than what this is looking at. Actually looks a little bit thicker than. Yeah, I think I want to do a little more research before we install this on the printer. Yeah. So I think we're going to call it here for the night, and we'll go ahead and resume this on Thursday. And like I said, I've already been watching the video. I'm going to continue to just do some research to make sure that we're going to mount this correctly. I need to make sure that we're getting the CPAP portion mounted correctly. And then printed torque wrench. There you go, Bob. We can fix that chimney issue with enough tannerite. Jackhammer, there's things that we can do. We can solve your problem there. But for now, we're going to go ahead and call this done. When we come back, I want to be able to get this mounted. And before we go too much further, it also gives me a chance to let these belts kind of sit with the pre-tension I gave them. I will look through and figure out how we want to, oh yeah, these are already feeling like they're loosening some. I need to figure out where to get things lined up. Like the normal thing is 150 millimeters between the front pulley and the pulley on the gantry, and then check for sound. I also have a West 3D belt tensioning guide, so I'm going to see how they suggest doing the belt tension. And based on that, we'll go ahead and tension the belt. And if I need to loosen the belts, then I'll loosen the belts up a tad bit and redo the zip ties on the back. If not, then we'll be good to go, and we'll put those front panels on just enough so that we can do our proper belt tension when the time comes. I either need to print out a torque wrench, or it says between 1.2 and 1.4, so I can print out a torque wrench, or I think the Slice Engineering one is that same 1.4, 1.2, 1.4 range. So I can grab the Slice Engineering one and use that. I'll check and figure out which way to go between now and Thursday. Regardless, I won't be hot tightening a nozzle at this point. I also, did this come with a nozzle, or am I going to have to provide a nozzle? So the short and dirty answer is there's not a nozzle in this particular accessories kit. There wasn't a nozzle in with the tool head, so I might have to provide a nozzle. I think I've got one that I can throw in here. I want to make sure that it's going to be a hardened nozzle though. So I think I do have an M6 threaded hardened nozzle. I might be a 0.8 from Fadis. So I prefer a 4 or a 6 though. Probably a 6. So we'll get some things prepped between now. I don't have an Undertaker yet, Zombie. So I can try and get one on order, but it probably won't be here in time. But like I said, I don't necessarily need the nozzle to continue going here. The nozzle is going to be needed in a couple of weeks. So yes, Zombie, I will probably get an Undertaker. Because I don't have an Undertaker yet. I will get an Undertaker. So, but for now, the good news is that we're going to continue with this build when we come back on Thursday. So I don't necessarily need to put everything up. I just need to be able to clean my desk back up for tomorrow. So, yep. The CHT clones that are the hardened CHT clones, yeah. It's because of the internal machining is crap. So the internal machining and whatever they use for the coating, see, that's the thing that they're not getting is it's machined and properly coated so you get better flow out of it. Like I am considering buying one of the the E3D bamboo nozzles simply because from the comparison that I just watched on it, it actually has better flow than the actual bamboo nozzles. Now, mind you, the 0.4 has been working great, and I have a spare 0.4 bamboo, like the hot end. You just have to pop the heater and stuff over to it, because it came with it, but that nozzle for the bamboo, yeah. So I'm thinking about getting one of those just to have on hand for when this foobar's. I could, and I have to swap it out. I'll just swap it directly in. Because it's not an if, it's a when. I mean, at some point you're going to get a clog or you're going to get something that foobar's on a hot end. Whether the thermistor blows, whether the hot end itself or the heating element blows, or whatever. Um, and the thing is, with a nozzle clog, it's easier just to pull it out, put a new one in, and be up and running, and then clear the clog later on, right? I mean, that's what I love about Revo. A Revo nozzle clogs. Okay, great. Unscrew it, take it out. You know, clip the filament, unscrew it, take it out, put a new nozzle in, and then when I get 3 or 4 nozzles that are clogged, then I will go about sitting here on the bench with the heat gun, heating them up, trying to get all the crap out of them and getting them unclogged so I can throw them back into my bench stock to have for another swap out, you know? So, yeah. Well, and so Bob, we had that issue. So I did have an issue with this that failed mid-print, and I couldn't get it, you know, I got all the filament that I thought back out, but it was still throwing an error with the filament sensor. And so the issue was there was literally some filament still stuck in that was tripping the sensor. It was cut, but it was partially pulled up and tripping the sensor. So I canceled the print, moved the printer over here, managed to get it heated up and pushed through. And that's when it dawned on me with the failover capability. My biggest thing was, could I do it fast enough that I didn't lose all the heat in the chamber because it was an ABS? Now I've got it figured out that even if I had to, I could power it down, unplug it, pull the whole thing to the bench, take the AMS off because I have no place to put that AMS sitting over there. So I need to move it over to the bench where I can have the printer sitting here, set the AMS at the back, pop the lid off, use my bench power to power the printer up, get it hot, push that filament through to clear the clog, put the plate back on, get the AMS going and get it going again, and I can recover the print successfully, right? So you're right, I can do that. I can get it cleared, but if I ever get a blob of death on it, or if it snags something and I bend the heat break, that hot end is coming out and I want to put something in it. And if I put something in it, I don't know if I want to go through and have to put on a heater, put on a thermistor, go through all that stuff. If I just buy a full hot end from E3D, it's 2 bolts out, slide the new one in, 2 bolts in, plug the wires in and go, right? It's just, that's what I'm looking at is, do I want to do that and have that on the bench ready to go? Or how much of the hassle do I don't know. I haven't made up my mind. That's where I'm at. I haven't made up my mind. Now, if an E3D, you know, bamboo hardened nozzle package shows up at my door, I'm not going to say no either. You had a lot of pullback issues till you put a riser on the printer. What do you mean there? As far as the AMS? The AMSs work perfect. The issue I've had with the AMS has been just spools not fitting. And so I've been just rewinding. I got 4 extra high temp spools. And I also have bamboo AMS or bamboo ABS refill coils, right? So the plan is I will run some bamboo ABS through here as well. But right now I'm doing specific prints for the Rook 2020 build. So I've got the Tugboat 3D stuff ready to go. I may have to reprint a part because my plan was to do an actual power supply under slung versus a power brick. And, you know, DC connector in the foot because I've had the power bricks. So they suggest using power bricks off of Amazon, and I had one fail at a show. So I've actually got like 3 of them because they're cheap, crappy, and they've got a well, I don't want to say non-replaceable. They have a soldered fuse inside of them. We found that out because after I bought one, I just told Evil Diesel while we were at the show when it failed mid-print, and we realized it was the power supply that Tango uniformed. I immediately bought like 2 or 3 off of Amazon, and he cracked it open, and that's when we realized that they've got fuses in them, like the standard glass fuses, but they're hard soldered in the damn thing. So you can replace them, but oh, okay, got you. So you raised up the glass to make an additional vent. So far when I was doing all my maker coins, I just leave the front door wide open. But if you're doing ABS and you want to leave the door shut, right, and the lid properly shut. But yeah, I get that. If you're doing PLA, hot air rises, so it could still get caught up in that top 2 inches, which is where the PTFE tube and everything's going. So yeah, that would make sense to do a riser for the to be able to vent the top glass. That makes sense. That makes sense. Okay, gang. Well, let's find a good, suitable raid target for this evening. Not sure who all is up and running tonight, but let's take a gander. Looks like the Jang, Science, of course, Big Jano. Arcaros, Maker Deck. Babe Ross is doing some painting. Declarations has some Dungeons and Dragons gaming going on. Astro Canuck doing something Mandalorian Lego. That's interesting. I haven't seen him do Lego before. Okay, Adrian. Okay, Adrian. Well, is up. Song of Strife looks like. What do you guys feel like watching, rating into? Ooh, you sent one to Westery that has closable vents and a place for your name. Really? Really, Bob? Feel like sharing it further? Link would be perfect. But yeah, anyhow, anybody got a raid suggestion? Anything that you heard off the suggestions that I had there from words on stream, basically. Anybody like any of the names that I called off, which are people that I just follow on Twitch? Anybody? All right, that would be awesome, Bob. I'd appreciate that. I'd appreciate that. Your choice, all are good. Okay, Mr. Wizix. Sounds good. I know we go over to Jano a lot, but I want to say It's Tuesday night, so he's not doing marbles tonight. Normally, he's doing marbles on Thursday. So let's potentially look. What else? I know we haven't jumped over to Babe Ross in a while. Said she's doing some painting, some abstract fantasy landscape printing. Declarations or Astro Canuck. We can go over. You know what? Let's go over to Astro Canuck. He's doing some Lego. We haven't done a brick builder lately. I'm going to go ahead and get a raid started over to Astro Canuck. Yeah, Lone Mountain Knife Company. Ooh, I have to check that one out. I got a raid started to Astro Canuck. Everybody come on over with me as we go over to Astro Canuck. We're going to stream again on Thursday. I do not plan on streaming tomorrow night. I plan on researching stuff tomorrow night for the Thursday stream. And then Saturday, we will be back to Black Box because I need to get that done and get into the tuning phase. That's going to be the longer part, as always. So thanks a lot, everybody, for being here. I'll see you Thursday night. Take care. And be on the lookout for Pez Liz late tonight. So thanks, everybody. Have a good one. Bye now.